So Ramanujan proved the summation of all natural number, and the proof is really astounding. Just because the summation of all natural number, that means the whole number, comes to end with some really fascinating terms. So here is the proof. So Ramanujan proved that if we take the summation of all positive numbers, so n equals to 1 to infinity, then we will get minus 1 by 12. So that's the thing he proved. So how can I prove that? The simple way to do is very simple. So you don't require a high level of mathematical degree to understand this proof. So let's jump into that. So take S for or S1. So S1 equals to 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on to up to infinity. So simply you can see, if we take the summation of this, what you will get. So for the first digit it would become only 1. When we will take second digit, up to second digit, it will be 0. Again it will be 1, and then when we will take the fourth digit, it will become 0. So basically it will back and forth between 1 and 0. So that means we will get 1 or 0, which means we can get the average. It's half, right? Summation of 1 minus 1 plus 1 minus 1 plus 1 minus 1 equals to half in a different way. So the different way is very clear. You just take the S1 equals to 1 minus 1 plus 1 minus 1 and so on. So after that, what you will do, you are simply S1 equals to 1 minus of 1 minus 1 plus 1 minus 1 and so on. So what you will do here, it's simply S1 equals to, it's 1 minus S1, right? So simply 2S1 equals to 1 or S1 equals to half. So you can get the summation result from here and there. So the second step is very important, just because it's derived from the first summation. So S2 is nothing but, we will take simple as that 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 and so on. S1 equals to 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. So if you take S2 here, you will be getting 1 minus 2 plus 3 minus 4 plus 5 minus 6 and plus dot 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 to infinity. Now what will happen if we subtract this from, so S1 minus S2, so it will become S1 minus S2, and you know, so 1 minus 1, which will become 0. So minus 1 minus minus 2, that means minus 1 plus 2, which will be 1. Again plus 1 minus 3, which will be minus 2. Again minus 1 minus minus plus, so it will be 3 and so on. right? So you will get this same result. So here you can see it's nothing but 0 plus s2. So s1 minus s2, it becomes 0 plus s2. So you can just simply do that. S1 equals to 2s2. So we know s1 equals to 1.5. So 1.5 equals to 2s2. So we will get the simple result, which equals to 1/4, and that's the result. So from here we have s1 equals to half and s2 equals to 1/4. Now the main part is the s3. Is our main thing, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 and so on. So now what we'll do, we will subtract x2 minus s3. So that's the point of this total equation. So s2 is 1 minus 2 plus 3 minus 4 plus 5 minus 6. So here, and we will minus 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. So here you will be getting 1 minus 1, which will be 0. Then minus 2 minus 2, which will be minus 4. Plus 3 minus 3 will be 0. Minus 4 minus 4 minus 8, right? So you will get to know that every odd number will become 0. So here is the plus 5 and minus, so it's plus 5 and it's minus 5 will be 0, and here again it's minus 12 and so on. So that's the thing. So what you can see, it simply denies that if we take the 4 common out of here, then we will have 1 plus 2 plus 3 plus and so on. So 4 minus 1 minus 4 into 2, that is minus 8, and minus 4 into 3, that is minus 12 and so on. So this is nothing but s3. So this is minus 4 into s3, right? So s2 minus s3 becomes minus 4 s3. So now what is s2? s2 is 1/4 equals to minus 3 s3, or we can simply write it down, s3 equals to minus 3 into 2, so it will be minus 1/12. So that's the equation. So we can write down it simply 1 plus 2 plus 3 plus 4 plus 5, and if we go continue up to infinity, then we will be getting minus 1/12, and that's what Ramanujan did, and that's the point of whole the mathematics. Is really surprised at the time